All right, everyone. Again, just write hi, please, in the chat so that I know who is with us. I hope you guys had a great rest of your Monday and Tuesday. I was up very late last night finishing up everything, and then of course just couldn't sleep, so continued to prep for the day and the week and everything. So apparently that's what happens when you drink a half a pot of coffee after 10 o'clock. So I made sure that I sent you guys the notes that I was going to use today. I'm not sure how many of you saw them yesterday, but I'm glad I did because apparently the table wasn't dry. So that's going to upset me. Anyway, today we're going to finish up with joint variation and combined variation. You're going to see that a lot of this stuff happens with physics and chemistry. You'll see it show up again in pre-calc, so there is quite a few different ways to do this, like I said the last time. Again, I went just to see what Khan Academy has to do with this, and I still believe the proportions by far are faster because you don't have to do the problem twice. So we're going to start with joint variation today. And it is similar to direct variation in that you're going to have a shared ratio. And notice how when we work these out, our K's are truly when you would write our problem. It looks almost like the direct variation from semester one where we would have our y equals kx. We did talk last on Monday about direct variation was that linear equation that had a y-intercept of 0. The difference with joint variation is it deals with two variables. So it has two things acting on each other. So in this case, x and z. And so once we would know one situation, we would be able to determine another situation given that pattern. So that's pretty much what all these variations are telling us, is that if we understand one situation that kind of sets the pattern for what we're talking about, we can use it to predict what's going to happen in another situation. So that's why I said a lot of times you see this in science. So because of the way this is set up, if we just continue and kind of use that transitive property where if they're both equal to k, they're going to be equal to each other, that's where all these proportions come from. So what we did was, again, started with, yeah, that's going to upset me, started with just our regular, pretty straightforward, doesn't actually apply to anything in the real world, but it is just practice. It says, suppose R varies jointly as V and T. Find R when V is 2 and T is 8 if R is 70, when V is 10 and T is 4. So again, our three steps aren't going to change. You are going to first determine which variation we want to use. So you can see already that I've identified that we're using our joint variation formula. So I wrote that down first. So step one, that's done. Then we have to label everything, and this time we have a y, an x, and a z. So in this problem, we talk about r, s, and t. Now again, when we label according to our formula, we have something that happened before the varies jointly phrase, and we have our two variables that happen after. So when we label these before varies jointly, regardless of what that variable is, and again, we've already seen where they've used x and z, doesn't matter, whatever this is, we label y so that it fits our formula. Directly after is x and z. Now that I know what r is, what v is, and what t is according to our formula, I then have to make sure that I find where the hypothesis still is, because that's the if statement. That's where all the yx1s, z1s are located. And our conclusion what we're trying to find is the y2s, x2s, and z2s. So the if and the find are going to be very important. So you can see that we've labeled the 1 for each, the 2's for each, and now we just fill in our formula. So with this, our y1 is 70, our x1 is 10, z1 is 4, y2 we don't know, that's our unknown, r, x2 is 2, and z2 is 8. And notice how, other than filling in the variable, I don't mention r, v, or t again. So when we do cross multiply, we end up with 40r equals 16 times 70, which is going to be 1120. Divide that by 40, and we find out our missing variable is 28. So again, I'll keep beating the dead horse, so to speak. Once we have everything labeled, the proportion is pretty easy as long as we have our formulas. And if you looked at any of this before we got started, one of the things that I did include, and I included it in last year's notes that I've already given you on Monday, but this kind of makes it easy if you have them in front of you. Again, I always talked about that note card that I kept from Algebra 2 and from Calculus that I had from high school. Having all of those kind of in one place, the stuff that I know I'm not going to remember, was always pretty convenient when I had to do work. So this would be something that you would probably want to have someplace readily available. So again, in all of your free time, which I know you don't have, if you are thinking of what else could I do that kind of raises the bar a little bit, that gets me prepared for next year, I would definitely start going through some things and kind of tallying up what's the most important stuff that I know that I'm not going to remember off the top of my head, and maybe put a little note card together. That way you have it. And this may be something that you want, because these proportions aren't always the way they're done. So if you go to Khan Academy and you watch a video, you will find that they'll do one problem, they'll use that variable to then apply it to the other problem, where in one step we have these proportions. All right, so let's take a look at our next example. Again, I have already set up the y's, the x's, and the z's, and this time it follows just like our formula. And so I don't even have to look for another if, because it's still a part of the hypothesis. We have our y1, x1, and z1. I noticed that my hypothesis, again, was finished, so now my conclusion, find, is in there. We're going to write out our formula, y1 over x1, z1, y2, x2, z2. And then we'll just fill everything in. So 12 over 9 times 3, and 6 over 15 times z. 12 times 15 is 180, so we end up with 180z equals 162. Let's make sure I did that right, because of course we can already see that some things are a little hinky, they're a little different than what we're used to. So 12, 9, and 3, 6, 15, and z. All right, so we're going to divide And instead of dividing by, I'm going to do it with the ABC button. And we end up with Z is 9/10. All right. Now, the other day I only had 3 examples. I did 2 that were pretty much the same, just like you saw today, and then a real world situation. I found a couple different ones. That way we can kind of look at reading what our context clues say. And in this next one, it says if P varies jointly as Q and R, so we have our Y, X, and Z, but we have to pay attention to, we're going to do something to that variable there. We're going to square it because it says P varies jointly as Q and R squared. So it's actually telling us to do something to the value of whatever R is before we even work out the problem. And here's our still part of the hypothesis. P is 25, Q is 4, R is 3. And then in our conclusion, we have P, Q, and R. So what we want to do, same steps. We are going to go ahead and label before the varies jointly so that we know what proportion to use. After it is X and Z. In the hypothesis, P is Y, so here's Y1. Q is X, so here's X1. Here is Z1. Here's Y2. Here is X2. Here is Z2. Y1 over X1, Z1, Y2 over X2, Z2. And I know some of you probably don't want to write the formula out every time. That's fine. I know every time I write it out, that's how I have it memorized so that I don't have to worry about what I'm doing. Y1 is 225. X1 is 4. And then it says Z1 is 3, but we want it squared. So that's why we're going to square this guy. And then that's going to be equal to P over 6 times 8 squared. And again, that's because it's telling us to take that R value and square it. And that comes in a lot, especially with area, when it's applied in, again, our science situations. You're going to see that it's going to tell us to do that. So we do have 225 over 36 equals P over 384. So then we are going to cross multiply, and we end up with 36P equals 86,400. When we divide, we get P equals 2,400. So nothing different really than the first 2 examples. We just had to make sure that we paid attention to that guy said squared. So first step, determine what we're doing, what kind of variation. Second step, write out your Y's, X's, and Z's. And the third step is to plug it into the proportion and solve. So I found a science example, and it says kinetic energy varies jointly as the mass and the square of the velocity. A mass of 8 grams and a velocity of 5 centimeters per second has a kinetic energy of 100 ergs. Find the kinetic energy for a mass of 6 grams and a velocity of 9 centimeters per second. So the idea here is we have to identify our variables, even though it's not as plain as P, Q, and R, we still have to identify what our variables are. So before we start doing that, let's determine what kind of variation it is. So we do see that it's joint. We know before the variation is always Y, so we are going to name that kinetic energy as our Y variable. After, if it's joint, there's going to be two things. So we can see mass is X and velocity is Z, but we don't want to forget that it does say that we're going to have to do something to that velocity. So we still have, before our conclusion, the word find is always going to be our help for what's the Y2s, X2s, Z2s. So we have mass of 8, so here is our X1. Velocity, here is our Z1. And the kinetic energy is our Y1. So it's a little they rearranged them, but make sure that you're still looking at what you labeled them initially. We want to find the kinetic energy on something that has a mass of only 6 grams, and we know that its velocity, suppose if it's lighter, it should go faster, is Z2. And like I said before, the hard part's done now. Now we just have to fill everything in. So we figured out what Y, X, and Z were. We labeled them in the problem, and now we're going to plug everything in. So we end up with 100 over 8 and 5, but it does say that we need to square the velocity, so we're going to square it. And we need to find our kinetic energy, so I'm just going to name it KE. And again, we have 6, and we have to square the velocity again, so that's why we have 9 squared. All right. Cross multiplying, well, let's simplify this guy out a little bit first. And when we cross multiply, we do end up with 200 times our kinetic energy equals 48,600, which means our kinetic energy when we divide is 243 ergs. Now, of course, some of you probably already noticed that, again, it's supposed to be, because joint variation is very much direct variation. They just have two variables with joint variation. You saw that this was 1/2 right here. That means this guy's going to have to be 1/2. So even before you did anything, you probably already knew what the answer was. So when we do this next part, obviously, you have already noticed that there is a pattern with everything that we've done, whether it's been direct variation, inverse variation, now joint variation. The steps aren't going to change. You're still doing all the labeling. You're still identifying what variation. You're using our proportions. It's now just make sure you have the right formula at the beginning. So keep that in mind. Before I push forward too far, I just want to ask, are there any questions? If not, we're almost done, because I don't think that I need to continue to explain the steps. We kind of get that. If you do have questions, go ahead and just ask in the chat, and I will keep going. Over here, with our combined variation, we do have situations where there is a direct relationship between two things, but with our initial item, it's very much could be an inverse relationship, meaning it acts opposite. We've done inverse functions already. So it's possible that it can relate one way to one variable, but a different way to another variable. So you are going to actually see two different variations actually listed now in the word phrase or in the word problem. And again, it all happens because of these separate problems that can be worked out. We can adjust them to make them equal to each other. And again, here's this proportion that we're going to want to use. So again, trying to save some time with the proportion. So here's the formula I'm going to take off of my note card or my formula sheet. And just like many of you probably already saw, here's the first example. And honestly, at this point, nothing has changed. It's just what formula do we start with. So first thing is determine which variation. So varies directly and inversely tells me that this is combined. Oops. So combined variation, that at least tells me what formula we're going to set up. And just like before, whatever happens at the very beginning is y. Whatever is directly after the first variation, so directly is always x. After inversely is always z. So once we have determined what our variables are now according to our formula, the second step is pretty redundant at this point. Label your x, your y, and your z, but again, pay attention. That's going to be the part that I think is the only pitfall most of us are going to have. We're going to have to make sure we figure out where the hypothesis is to put our ones and where our conclusion is to put our twos. And be careful, make sure that what you've labeled y stays y, what you have labeled x is x, and what you have labeled z is z. What we have trouble with is we start to put them in order as they are given, and that's not necessarily what they match with. So that's why this first step is so important. So we have our x1, y1, z1, 2, 2, and 2 labeled. So plug them in. y1 is 4, z1 is 20, x1 is 2, y2 is -5, z2 is t, and x2 is 10. So when we do cross multiply, we end up with -10t equals 800. And when we divide, I did what you guys do. I went to my calculator to see if I was right. It's early still. When I divide, we're going to end up with negative 80. And that's it. I do believe, again, that this is a pretty straightforward section. It is still that this second part is going to be the most difficult, labeling and making sure that we continue to go back to what our original labels were. All right, almost done. Okay, you can see that I've already taken care of the first step here. We've identified what kind of variation this is. We then need to label our y, x, z, and I get it. It's redundant. I just like patterns. Keep things the way it should be. Here's our if. So here is y1, x1, z1. Here is y2, z2, and x2. And plugging everything in. We have our proportion. So I guess one of the reasons I had this problem still on here was specifically just to kind of prove that these are pretty quick if you have everything you need and the steps in front of you. And like I said, probably most of you wouldn't even go through the labeling in this one just because they are the y, the x, and the z. So the last two, you can see already there's this word, the square of h. So again, the only thing that's going to be different in this one is we're going to have to do, we're going to have to square a number before we plug it in. And then I do have our science problem that's going to go with this in a little bit. So we have varies directly and inversely. Before directly is our y, after is our x, and the square of h, here's our z. Still in the hypothesis. We said f was y, so here's y1, g was x, x1, h was z. Here's the word find, so y2, x2, z2. Again, still a pretty quick process because at this point, the hard part's done. And there's our formula just to keep everything straight. And we have y1 is 20, z1, oop, I forgot a 1, that's going to bother me, is 5, but don't forget we have to square that. We don't want to forget that it does say square it, so we want to make sure that we do that. Over x1, which is 50. Then we have f times 6 squared over 18, and we don't want to forget that we had to square that as well. Cross multiplying, I'll simplify first. And then when we cross multiply, you do end up with 1800F equals 9,000. So F is 5. All right. Again, as we go through this, if you have any questions or comments, just ask. But I know this is pretty much the one we were waiting on, is just making sure we can do this when it's all kind of lost in actual word problems. So here is our varies directly and inversely. So if we can identify where those are, that helps us figure out where our y, x, and z's are going to show up. We said before our varies directly is our y, so this electrical resistance, meaning how much can a wire actually hold up to. So when you see wires kind of spark, it does mean that there's less resistance for whatever the power is. So there's our electrical resistance. That's going to be our variable y. We have varies directly with its length. So our length is our x. And then it says as the square of its diameter. So a wire actually does have a diameter to it. And I know those of you that may have actually gone to a craft store, they talk about the gauge of a wire, and that's actually how thick the wire is. But don't miss, again, the fact that we're going to have to square that. Here's the word find, so we know anything after that is going to be our 2's. So right away up here it says a wire with a length of 200. So here is our x1. And a diameter of 1/4, so diameter was z, has a resistance, that's y, of 20 ohms, meaning how much can it hold on to without it giving way. So here is our y1, so we have our x1 for the length, our z1 for the diameter, and our y1 for the electrical resistance. We want to find how much a wire can resist. So here is our y2 in a 500 inch, that's our length, with the same diameter. Now here is our z2, but I'm going to make sure that I know that when it said same diameter, that I again use my context clues to make sure I know that that's actually a 4th, that the gauge of the wire is going to be the same. Y1, oops, Z1, X1, Y2, Z2, X2. And now we plug in. So Y1 is 20. Z1 is 1/4, and again, we're going to square it. And X1 is the length of 200. We don't know what our electrical resistance of the new wire is. It's going to have the same diameter, the same gauge. over 500. Well, this is actually, if I square 1/4, it'll either be 1/16 or that decimal. And when we cross multiply, I'll just cross multiply that as it is. So we end up with 12.5 ER equals 625. And when we divide, we find that our electrical resistance is 50 ohms. Meaning this guy can actually hold up to more electricity than the first one. So, if you are like me after doing a bunch of these problems just for the notes, it got a bit redundant because the process doesn't change. I do think it's a lot easier, again, than having to do multiple problems, but definitely will come in handy again with our science and pre-calc stuff. So, are there any questions? Because now you should have the capability of finishing those 16 problems. You did see that I did update everything in the grade book. Most of it very late last night, where I got stuff ready and finished up some stuff. But if for some reason there is something that you still wish to hand in, please email me. They told us that, you know, Friday is the end-all be-all, but get whatever you have to into me before then so that I can take care of it. But you technically have till Friday to get any of the late work in. This set of problems, these 16 problems, they are due on Monday, so it is the first grade of the fourth quarter. If you feel like you need to meet on Friday, I will put a question out there in Google Classroom just to see if you need to meet. If we have a resounding we don't need to meet, let's just get the worksheet done and we'll be back on Monday, that's fine. So if there are questions, go ahead and ask. I'll kind of get cleaned up here. If not, I will either talk to you on Friday or on Monday. I would like to also reach out and say that there's just one or two in your class that I'm having trouble contacting still. If for some reason you have some friends that you know should step it up a little bit, not take advantage, I suppose is the phrase, of our situation. I mean, in hindsight, I suppose we could all say we're very lucky where we're at, that it does absolutely stink that we're kind of stuck behind closed doors, but it is helping, keeping everybody safe and healthy. It definitely could be much worse. There are definitely students in history who have had things much worse. So if for some reason you know some people out there that need to, you know, step it up a little bit, get refocused, they have the means, they have the capability, they're just choosing to, I don't know, sleep in till 3 o'clock or play video games all day. You know, let them know. We gotta stay focused. We gotta keep ourselves motivated. So, if there are no other questions, I will see you guys either Friday or Monday.